today's lesson we're going to talk about the real number system. And in terms of real number system, classify numbers really talk about having sets of numbers, and a set is just a collection of distinct elements. And when you write those elements, you always put those elements in braces. So when we do with a set, we're talking about a collection of elements that are listed within braces. If we talk about the empty set, sometimes you hear that as the null set. It means if there's nothing a part of that set, if there's no elements, you can write it symbolically with that circle and a slash. So when we deal with counting numbers, or sometimes they're called natural numbers, think about when you were a kid. The first number you really learned to count from when you counted on your fingers was 1. So counting numbers are the set of all numbers starting from 1 and then going all into infinity. You notice how they're in braces. When you deal with whole numbers, when you got a little bit older, you learned about the concept of 0. So whole numbers happen to be counting numbers including 0. So the set of whole numbers would have a starting spot with 0, 1, 2, 3, and on to infinity. Then we start talking about integers, probably when you maybe got into some of the upper elementary school grades or maybe middle school. But when you start talking about integers, all we're dealing with that is the whole numbers and their opposites. So integers then just become all the whole numbers and their opposites. Well, 0 doesn't have an opposite. Okay, so when we talk about integers, just open up your set notation. You're starting from the negative of infinity, so negative infinity to like -2, -1, 0, 1, 2, 3, and on to positive. Then again, as you get a little bit older, you start talking more about the concept of rational numbers. And rational numbers are any numbers that can be written as a fraction. So any number that can be written as a fraction. So terminating decimals and repeating decimals, they are a part of rational numbers. If you think about a terminating decimal that ends, think about the number 0.5. Well, that's just a fraction that's equivalent to 1/2. So terminating decimals are also rational because any number that can be written as a fraction and then as a decimal that terminates counts as that category. So another example might be, let's say like a fourth, because that's a fraction, so therefore it must be rational, but it's a terminating decimal because that's just 0.25. So terminating decimals are also rational numbers. Repeating decimals is the same idea. So if you think about a number that can be written as a fraction, which makes it rational, 1/3, well, that's a repeating decimal. That's 0.33333, and so on. So terminating and repeating decimals are just types of rational numbers. And remember, rational numbers are anything that can be written as a fraction. So if you're not rational, then you are irrational. And so irrational numbers happen to be decimal numbers that neither terminate nor repeat. So these would be decimals that neither terminate or repeat. When we think about irrational numbers, we tend to think about numbers like pi. So the symbol for pi. Pi is a number that goes on forever and ever and ever and never ends and never repeats. We might terminate it to 3.14, but that's not what pi is. Pi, again, is a really long number that goes on forever and ever, never terminates, and never repeats. Other irrational numbers are square roots that are not perfect squares. So like the square root of 4 is just 2. The square root of 5 is this long decimal that never terminates and never repeats. So symbol pi, and we're looking just for the symbol, or if you think about square roots that are not perfect squares. So really those are going to be the only, not the only, but those are based on the majority of the two numbers that are going to be considered to be irrational. In terms of real numbers, any number that we deal with in this math class is going to be a real number. So these are going to be all numbers, rational or irrational. a nice little graphic organizer down here that talks about what types of numbers are what. So anything in this box, all of these things happen to be real numbers. We can separate real numbers onto two big categories. We've got rationals, and then we've got irrationals. If we talk about rational numbers, you'll notice that on the inside, you've got these natural numbers, these counting numbers. And that's a part of the bigger group of whole numbers where we now include 0. And then we get to the integers, which are whole numbers and their opposites. And on the outside, you see these fractions. And you see repeating decimals and terminating decimals and fractions that are negative and perfect squares. Okay, so those are all your rational numbers. Irrational numbers, what you're seeing is the symbol pi, square that doesn't work, and then here's a number that does not end and does not repeat. So here are some examples of things that you'll be doing on your homework. The first one is name all the sets to which the numbers belong. So 7 happens to be counting. It happens to be whole. It's an integer. It's rational. And everything is going to be real. 0.6 repeating. Well, it's repeating. It's rational. It's real. And that's it, because it's a decimal, so it's just going to be rational. Radical 71. It's a square root, but it doesn't actually come out as a perfect square, so it's irrational, and it's real. Negative 81 over 3, it's a fraction, so it has to be rational. It has to be real, but if you think about simplifying this fraction, it turns into negative 27. Negative 81 divided by 3 is just negative 27. Well, negative 27 happens to be an integer. Okay, so that's what you've got there. This next one happens to be a perfect square. The square root of 169 is 13, so this answer comes out to be negative 13. And then it's the same thing as what we just did. This happens to be an integer. It happens to be rational. And it happens to be real. Okay, so this should be good to get you started on your homework. All right, so good luck with that.